Okay, now for collisions, when two objects collide, the sum of their momenta, the vector sum, that has to stay the same. So the vector sum of the momenta stays the same whenever two objects collide. Every time. That's always true. We have some other cases when it's not, when other things are true, but this is going to be the case that's always true. If it's a collision between two free objects, the momentum stays the same in that collision. Now, if something's fixed to the post or something like that, then it might be a little bit different, but as long as two things are free, that's okay. So the thing here is, if for a physicist, right, if I had a ball that came over here and bounced off, this is not a collision, this is a deflection. And momentum is not conserved. Okay, momentum is not conserved for this guy. But if I had a ball come here and bounce off another ball, like that, this ball would start moving that way, and that is a collision. So that's what we mean by a collision. Right? And the only thing we know for certain before we start talking about exactly what kind of balls they are and what sort of surfaces they're on and all those other fun things is that their momenta before and after are the same. So the sum of these guys are the same. So this is just like conservation of energy, only it's a vector sum. So that means in all three directions, the number is in each of the three directions, the number is the same. Not for all three directions, but for each of them. So let's see. Let's pull out a different color for this. So if I had like let's call it 3 and 2 here, and 1 and 5 there. Oops. Then when I add these up, whatever I have for Q and Q here have to add up in the X direction to be 4 and in the Y direction to be 7. So that would be, I could just have 4 here and 0 and 0 and 7. It's not completely general, but the momentum is conserved because 3 plus 1 equals 4, and 4 plus 0 is equal to 4, and 2 plus 5 is equal to 7, and 0 plus 7 is equal to 7. So that momentum is conserved. So in every direction, the momentum has to be conserved, each and every one of them. All right, that's true for every collision. I'll have somebody run into a refrigerator or something in just a minute to show you how that works, and then I'll come back and I'll talk a little bit about more specific kinds of collisions. All right, bye now.